SFBBO, promoting sustainability by engaging communities for more than 40 years. Our Birdie Hour speaker series is a free virtual program. On January 28, 2025, SFBBO's Director of Waterbird Science, Dr. Nathan Van Schmidt, gave a talk called Flows of Water and Waterbirds Across California to share his research with our community.
I am a science director at San Francisco Bay Bird Observatory working on two programs. One is our longstanding Waterbird Science program. The second is what I'm calling Resilient Regions, which is an interdisciplinary land use and climate change planning program, which has been, and my work history has been a bit of both of those things. I've worked at USGS, UC Santa Cruz. I got my PhD at UC Berkeley. And I'm going to be drawing on a lot of different research from several of those different paths I've taken through my career in ecology in this talk, and talking about how waterbirds landscapes intersect. And I'll be keeping it a bit lighter on science, a bit more focused on storytelling, but we will talk about some theory and have some good figures as well. To get us started here, I'm going to show this satellite map of California. And if anybody is looking at this, they might notice a few things wrong with this map of California. Primarily that there is a big lake at the south end. There's no farmland, there's no cities, and that is because this is a reconstruction of a satellite map, what it would look like in 1851 before the bulk of European colonization. That wetland you see is what was once the largest freshwater lake of the western U.S., Tulare Lake. Today, it looks more like this. Everything has been drained and converted to agriculture. Tulare Lake is no more. It is now farm fields, as most of the wetlands in the Central Valley are. What happened with that? Well, we all know what happened in California. It all begins with the gold rush in 1949, hence why we start with that 1851 map. This began a remarkable transformation of pretty much all of California's ecosystems, including here in the Bay Area, where SF served as the main port of entry for the gold rush and many immigrants. Because of its central nature in the middle of that transformation, SF estuary began to change really rapidly. This was one of the first parts in California to begin experiencing many of the changes that came to define the transformation of the state overall. The first changes occurred further up in the estuary in the delta, closer to Sacramento. This map shows the infill dates of wetlands by time. Many of those wetlands in the delta were drained and converted to farmland. There are now major issues actually with the peat fields there, essentially evaporating to the air, causing big carbon emissions and major land subsidence. Many of those areas are now at risk of flooding under sea level rise. And in the center of the bay, we saw land filled in with trash. It was also then subsequently built on top of. And then down in the South Bay in particular, especially in the 1900s, we saw a lot of land drained and converted into salt production ponds for sea salt. This wasn't an overnight process. Many of these changes did take place over decades, but they were largely complete by around the 1970s when this process reached its endpoint. That endpoint was the widespread loss of tidal marsh habitats. Tidal marsh habitats are defined by the tidal cycles. At high tide, water comes in and floods these vegetation fields, which are usually dominated by short herbaceous species like pickleweed. And then at low tide, the water goes out and exposes mudflats at lower elevations. There are a number of special status species that are adapted to this. One is Ridgway's rail, which is federally listed, large and relatively conspicuous for a rail species. These birds like to run through the pickleweed on those big feet pictured here. California black rail is another one, very difficult to see. Even my presentation seems to be having trouble. Let's give it another shot here. No, that's just more pickleweed. Almost got him. All right, there he is. This is probably the most secret waterbird in all of North America. He's very small. He runs through little vegetation tracks deep in wetlands underneath the vegetation. I'm sure that plenty of the birders on this call have tried and failed to see one, but they do a very distinctive set of calls, which I'll be touching on later as I did my dissertation work on this species. There are also some other species that are not birds that I don't know. I guess some people care about not birds, like this very cute salt marsh harvest mouse, which is also federally endangered and depends on pickleweed marshes to survive. One species you might not realize is dependent on tidal marsh is humans. Tidal marsh are some of the best possible defenses we have against encroaching sea level rise and associated flood risk, particularly flood risk during storm surge events. And lots of communities are at risk of sea level rise under climate change throughout the Bay Area. As a result, there have been major efforts to restore tidal marsh habitats across the entire Bay Area and really the entire Pacific coast to protect both species that depend on tidal marsh habitats and the communities that live in those low-lying areas. Those communities themselves are often economically disadvantaged because they live in flood-prone areas. If you look at this map on the right, you can see a lot of the planning for what's going on here. And it's worth noting that the North Bay is further along in this restoration process, while here in the South Bay, this has really just gotten started in earnest in the past 2 decades or so. In 2002, when work in the South Bay began to get started, this is what the landscape looked like. Wetlands had been drained and converted into salt production ponds, which were owned by Cargill Salt. Cargill pumps water into the green ponds and then transferred them gradually from pond to pond, where it evaporates and gets saltier and saltier. And then the red ponds here are the saltiest ponds, which then are eventually moving into the bright white ponds where the salt is harvested. In 2002, the U.S. Fish and Wildlife Service and the State Fish and Game worked to buy a large number of these ponds, excluding the red complex, which are the Newark and Maori ponds here, as well as the complex just north of that around Kylie Hills. Let me see if I can get a laser pointer here. Yes, right up there, where there is, they are managed for salt production still, but owned by Fish and Wildlife. The project aims to restore between 50 to 90% of the ponds to tidal marsh. To date, the brighter green ponds in this image have been restored so far. Ravenswood Pond R4 was breached just 1 year ago. That was the most recent action. But most of the ponds, the ones that aren't bright green, that are a bit duller green, have not been transitioned into tidal marsh, but are still ponds, but are now managed wildlife ponds. The primary difference between them is the dropping of the salinity into more normal brackish water levels. There are complications, however, for restoring these ponds. One big issue is that the ponds are already used by birds migrating in the Pacific Flyway as is. This flyway is a globally important migration route between breeding grounds for waterbirds in the polar regions and wintering grounds in Central and South America. Within California, it has 2 main coast routes, one that is along the coast here, which San Francisco Bay is part of, and route that is primarily defined by the Central Valley. Every year, over 1 million waterbirds use this San Francisco Bay as migratory habitat or overwintering habitat, and many of those waterbirds are in the salt ponds. The record Christmas bird count for raw abundance of birds was in Don Edwards National Wildlife Refuge within the southern part of the complex. So a big question is what the impact on these birds this restoration project might have. And there are a lot of birds that use them. This is a list of all the birds we are currently tracking within the project footprint, broken up by foraging guild, which is the main way we analyze this. Small shorebirds and medium shorebirds are two of the most important guilds for looking at the Pacific flyway. Herons and egrets are less abundant, but very big and top predators, so they are often useful indicators for wetland health overall. And we have many other guilds as well, like fish eaters, diving ducks, including my favorite personal waterbird, the bufflehead, dabbling ducks, terns, gulls, and in particular, the bone part gull, which is pictured, that is a saline habitat specialist of particular interest, as well as two other saline specialists, phalaropes and eared grebes. These are birds that are primarily inland in the Mono Lake, Great Salt Lake, all of these inland Great Basin terminal lakes that get very salty. And surprise, surprise, those birds also really like the very salty salt ponds. So those three groups on the bottom were of particular concern when we're talking about moving things away from salt production. So when the restoration project commenced, a monitoring project, a long-term monitoring project commenced as well. SFBBO and USGS have been going out to every pond with a scope, driving around the levees, and counting every single bird out there. There are mornings I've been out there counting over 4,000 ruddy ducks before 8 a.m. In many respects, that is a dream come true. It's a dream job. In many respects, it's also reminiscent of a stress dream where somebody is like, your job is to count every single duck on San Francisco Bay. It's definitely a bit much at times, but our field teams do a great job powering through the bulk of the winter when the abundances are at their highest. We conduct these in fall migration, winter, and spring migration. And then we analyze the data based on each of the guild's main season. For instance, the ducks, we're looking at they use the ponds as wintering habitat, so we look at winter. I'm going to go over some of the main trends and findings from that now. So for many guilds, the trends are looking pretty good. Dabbling ducks responded very well to the initial stewardship plan, which took place in 2003 to 2005, right after they bought the ponds. This was when many of those ponds were transitioned out of these hypersaline salt production to a lower salinity, but still salty, wildlife ponds. You can see that within the South Bay Salt Pond Restoration Project, which is the blue line here, their abundance skyrocketed during that time period. Well, in the ponds that remained in salt production, it stayed pretty flat. And then black line is the total bay-wide trend. Diving ducks and ruddy ducks also responded very positively after that kind of initial period. Although in all of these trends, we can see a little bit of a worrying, more recent trend of declines as well. But the initial plans seem to be working fairly well. Medium shorebirds in the winter have increased fairly consistently for the first decade of the project before leveling off. And small shorebirds did as well, particularly in their fall migration. You do see these, again, some degree of up and down cycles in these graphs. This is very common in population dynamics over long time periods because of factors like density-dependent regulation, where population might become too high and food sources become scarce, or disease transmission becomes more prevalent, and then the population will fall again. So that's one potential factor, but it could also be habitat changes, which is one of the big questions we have, is what's driving those. We also have 4 key species of breeding shorebirds and terns. These have been found to strongly prefer managed ponds and non-tidal marsh. These bar charts show how much each habitat type is used relative to its availability. This is work done by our partners at USGS. Bars that are above 0 here show strong selection for this habitat type, and bars below, strong avoidance. And you can see that the managed pond habitats have the greatest abundance for many of these species. But there's a catch here. This is non-tidal marsh habitat. If you look at tidal marsh and tidal mudflat, these are actually avoided for several of the breeding species in this region. So if we think about that, we can see that eventually this might start to be a major problem. As I've mentioned, most of the changes that have happened so far are moving ponds from hyper salty to less salty habitats, but they're still fundamentally ponds. They're open water habitats where shallow open water stretches are great for something like a dabbling duck that might like to sit and feed with its butt in the air, or a shorebird that's going to walk along and probe in the mud for food. But eventually, once those ponds are breached, sediment begins to get deposited, vegetation slowly regrows, and that is likely to reduce habitat for waterbirds. The pond changes back into this tidal mark dominated by pickleweeds, which is great for rails, but not a lot of areas for a duck to swim around in. On top of that, there are even more complications, very cute complications like the western snowy plover, which also occurs within the project footprint. SFBBO also has a program monitoring these species run by my colleague Matty Schwartz. Snowy plovers don't even like open water. They like it when the ponds are totally dried out, forming a salt pan rather than a salt pond. You can see that the eggs in this habitat, visible right here in the center, are camouflaged really well. And the birds themselves are also camouflaged quite well. In particular, on this pond, you can see oyster shells have been spread out across this habitat. And that's because as they continue to restore ponds to tidal marsh, they're also going to have less of the salt pan habitat. And as a result, they've tried to do this oyster shell enhancement approach. Predators cause about half of all nests to fail, which is one of the main factors limiting recovery of snowy plover populations, who are also a listed endangered species. So one of the ways they've tried to offset the loss of habitat is by enhancing the remaining habitat by scattering these shells across it. The oyster shells make the birds much more confused, and they can't see the where the birds are, and hopefully that reduces predation as well. And we do see some success on this front. Very important animation right there. So this has proven successful in recent years. We are still below the SFA recovery goal of 500 birds, but we are starting to get there with the overall breeding trend within this region. We also have the least turn, which Maddie's program, the least turn watch, also tracks. This is another threatened species that breeds throughout the Bay Area. They've been found all the way up from that delta down to Eden Landing. And they've been present since the start of the project, but disappeared from the project footprint in the late 2000s, persisting only in the remaining salt production ponds. For most of the past decade, they've largely persisted there, while within the restoration footprint itself, shown in blue here, they've been largely extirpated. All of that is because these birds prefer this non-natural anthropogenic habitat. This habitat is a dried out salt pan that historically would not have really been here at all. There were very small patches of salt pans in the area, but not to the extent that they were once the salt production companies moved in here. You would have seen something like this, a number of channels moving through a landscape, but it would have been dominated primarily by flooded pickleweed marsh with the sloughs. So obviously we do need to conserve these birds, but we need to think about that in the context of both the historical and broader range of the species. For snowy plovers, salt pans are not their usual habitat. On most of their range, they're a coastal bird, living on dune-backed sandy beaches and river bars. And the same thing is true for least terns. On the coast, they're largely on sandy beaches and lagoons, while in SF Bay, they are on constructed islands, some of which have been constructed specifically for this purpose, again, to make up for the fact that the number of ponds overall is shrinking. They also nest on old runways on Alameda Island. So this is very strange. We have two listed species, both are threatened, and they are both found locally entirely in anthropogenic, unnatural habitats. And one of the reasons they're here is because their natural habitats are also highly disturbed anthropogenic habitats now. Beaches are covered in tourists. and these small fluffy white monsters that you can see in the bottom left here. There are also drones, recreation, habitat loss to development, like Santa Cruz Boardwalk on the bottom right here. And as a result of all of that, we see that birds are no longer using what would be their natural, normal habitat, and have instead come to rely on anthropogenic habitats within South San Francisco Bay. We're going to put a pin in that for now, as we think about all the other water birds that rely on this habitat as well. And I want to shift gears for a moment to talk about those other water birds. I had mentioned the saline specialists, Bonaparte gulls, eared grebes, and phalaropes before. They like very, very salty water, like salt ponds. And the adaptive management plan of the project called out early on that they might need special attention to ensure they didn't decline. So they set up thresholds shown on the dash lines here, where a deadline or a decline is considered significant to determine whether project actions might be causing a decline. All of these are again generally found in the saline lakes of Great Basin. And in the South Bay, we see some worrying trends. Both phalaropes and Bonaparte gulls have declined pretty much continuously since the start of the project. Cost trigger thresholds in the adaptive management plan. Eared grebes have done a bit better, but only thanks to the ponds that have remained in salt production in the green line here. Within the blue, on the blue line, within the restoration project footprint, they've been pretty much extirpated as of the past couple of years. So let's look at phalaropes as an example here. In case you're not familiar with them, I do want to highlight these unique and fascinating birds. They are the highlight of our t-shirts that we gave out this year, that Kristen put together, and they are beautiful. They're similar to sandpipers, but they spin in tight circles to forage. They kick out water in a circle as they're swimming, and as they're pushing water out in a circle, that creates a vacuum in the center, actually, because the water is getting removed. And to fill that vacuum, the water gets pulled up from underneath, from the pond bottom. And when it gets pulled from the pond bottom, it carries invertebrates with it that these birds then pick off the pond surface. So if you go out and watch them, you can see them spinning for hours like this during migration, when they stop over in these hypersaline habitats to gorge primarily on alkali flies. They're a very specialized feeder. They also overwinter in salt lakes down in Argentina, Laguna Marshakita being the biggest one, as well as several other areas that are threatened by mining for metals in the salt pans down there, lithium mining. One last very interesting thing is that they have reverse sexual dimorphism. The males do almost all the parental care. They're the ones that sit on the nests, while the females, which is what's shown here, are larger and more colorful. So if we go back to that graph of decline and expand the scale on the graph here, I think their decline is even more obvious. Decline counts have declined more than 50% since the 2004-2006 time when the salt pond restoration project began. And one of the big questions we wanted to investigate was whether this decline was caused by restoration management project actions, which is it's hard to attribute a change in a population to a driver. So we wanted to see what we could figure out and do some detective work, which is a lot of the most fun part of science, in my opinion. If we investigate what's going on, we find some confounding patterns, though. We would expect, again, that as salinity declined, these saline specialist birds would also decline. But when we fit habitat covariates to the changes to try and find correlations, we found the opposite, actually. This graph shows the strength of relationships between changes in habitats and changes in populations. So everything on the left side of the graph is showing off a inverse relationship. So as the habitat measure goes down, the birds go up, or vice versa. And on the right side, those are positive relationships. So salinity goes up, population goes up, which is what we would expect to see, a positive relationship between the two. We don't see that. The strongest relationship of phalarope count drivers at the pond scale and changes in phalarope counts at the pond scale is an inverse salinity relationship, where the ponds that fell in salinity actually saw the bigger increases in population size, the opposite of what we would expect to see. This was a very surprising result that was and to a certain degree is still quite confounding, and we're investigating what's going on here. But to try and figure out what might explain this, we decided to look at some other data sets as well. If we look at Wilson's phalarope, which is the species we have the best data for, there's also red-necked phalaropes, the other species we're looking at. In 1986, the last time before our data set there was a range-wide survey of populations, we found around 40,000 birds. There were also around 40,000 in Mono Lake. So these were so the population in San Francisco Bay was actually really significant. It was one of the largest populations in the survey. In 2023, when we surveyed, this was down to 1,000 birds, which is a 98% decline. Even more significant than the decline we saw in the surveys that began in 2003. So that suggested that the decline might have predated the restoration project and could be potentially driven by other factors across the range rather than shifting habitat conditions within San Francisco Bay. Because our surveys only started in 2003, we turned to eBird to look at population trends before then. So if you've ever taken the time to upload old pen and paper checklists to eBird, thank you. That data does get used. The trends that we're looking at here are from before even the launch of eBird. And if we go back even further before the restoration project, we see in that old variability that there is some really high counts going back through the 1990s and some really, really high counts back in the 1970s and 80s. This is on a linear scale here where we can see these are the monthly kind of mean corrected counts. So the measure is a bit hard to interpret, but you can see that there were these absolutely massive counts that have, even since the start of the project in the 2000s, have never been seen since. If we do a log transformation, we can see a more consistent decline. And if we fit a graph to that, we see this, or if we fit a trend line graph to that. And one of the other things we fit this trend line to was looking at Mono Lake and the rest of California versus San Francisco Bay. And that timing does suggest the decline predated restoration project actions and wasn't necessarily the fault of the restoration project. But if we fit a trend line to those data and compare San Francisco Bay to the rest of California, we do see that the decline locally is still much more severe than anywhere else in California. The important thing here is the relative slopes rather than total abundance, because detectability of birds is really much lower on Mono Lake because it's so big. But we see that slope is very severe in San Francisco Bay and pretty flat elsewhere. So the decline predates the restoration project, but it is unique to San Francisco Bay. So what's the deal here? Well, unfortunately, California isn't the only place undergoing a big transformation. Phalaropes are bellwethers of saline lakes and are affected by everything else happening to those systems as well, which generally is not good. These ecosystems are in danger of collapse worldwide. Collapse is a big word, but it's accurate in this instance. Several of the saline lakes already have pretty much collapsed as functioning ecosystems. This is a picture of Great Salt Lake from the air in December 22, which is what you see on the right. The lake level had dropped to a record low. This concentrates the salt, increasing the salinity beyond what even alkali flies and brine shrimp can tolerate. And it reached the brink of a tipping point where it would have been too salty to support those invertebrate populations that the birds rely on in food in 2022. It was rescued kind of at the 11th hour by a single extremely rainy winter. Because of the threats to these birds elsewhere, I joined with several other groups of scientists in petitioning the government to list the phalarope, Wilson's phalarope in particular, as threatened under the Endangered Species Act to try and get some protections for these ecosystems, which are pretty imperiled. Great Salt Lake is not unique in this. This is Lake Abert, another saline lake in the Great Basin. It had almost entirely dried out in the past decade as these mega droughts hit California. And at the time, phalaropes appeared to have abandoned it altogether as a migratory stopover. But when the rains came, this again flooded, and we have seen the phalaropes again using this habitat in the past couple of years. It's not a big mystery why these lakes are drying up. If you look just east of Lake Ebert on Google Earth, you can see that there has been widespread upstream diversion of water for agriculture, which is the primary driver currently causing the collapse of these lakes. Great Salt Lake is the same. Mono Lake would also be very imperiled, except as a court order protecting it. But nonetheless, a large portion of its water is diverted down to LA, which has negatively impacted populations of some species like California gulls and other birds as lake levels have fallen, and the breeding islands have been exposed to predators that can walk over newly formed land bridges. Ironically, this has displaced many of the California gulls to the Bay Area. They now imperil the snowy plover nests as predators, as again, more birds are crammed into a tinier amount of habitat. And this isn't even localized to the United States. If you look at Aral Sea in West Asia, it has basically collapsed as an ecosystem due to water diversion. All of these issues are going to become even worse under climate change. These diversions have weakened an already fragile ecosystem to the point of collapse. And as the weather gets hotter and drier, and especially more variable in precipitation, there's a real risk that we could see widespread collapse of multiple saline lakes at the same time, which could be catastrophic for these saline specialist birds. As we mentioned, they were able to abandon Lake Ebert, but they were able to do that by going to Mono Lake and Great Salt Lake. And without that kind of ability to absorb these shocks, we could see much more severe ecosystem impacts. So let's zoom out to California again overall. We can see San Francisco Bay here, as well as Lake Ebert up here, Mono Lake down here. And the birds migrate within the Pacific Flyway over a very large landscape. Think about those connections between those ecosystems, and they can shift habitats, as I just said, depending on what conditions are in different areas in any given year. We don't know exactly what the impacts of those shifts are, if it increases mortality, for instance. And those are pressing scientific questions, but we do know that they can shift from year to year. And the great wetlands that filled the Central Valley 150 years ago are 90% gone, saved only within a few refuges. Across California, birds are now reliant on these anthropogenic habitats across all of these different species and guilds. We see the same patterns. With that, I want to jump back for one final example and one final complication to the gold rush and my dissertation work. In particular, let's look at the heart of the gold rush, gold country, the Sierras north of Sacramento. I promised we'd talk a bit more about black rails. And while yes, within San Francisco Bay, they've declined due to the loss of tidal marsh habitat in the gold rush harmed them there in the Bay Area. It appears to have actually likely led them to colonize gold country. I took this picture one morning during my field surveys in Yuba County, and this is what gold country would usually look like in the summer. Very dry, lots of grasses between oak woodlands, much like Mount Diablo and the hills around the Bay Area. But this was taken from a wildlife refuge, and most of it doesn't look like that anymore. Most of gold country today looks like this. It's more green than gold. You can see cattle dotting the hillside, and to feed those cattle, humans have installed an irrigation ditch at the top of the hill. That irrigation ditch up here floods irrigation water down the hillside for forage, which then pools in the valley here and creates a small wetland. And within those tiny patchy wetlands, we find black rails. This was not expected to be here. It was not discovered until 1994 in the region by this man, Jerry Tecklin, a great old field hand who was working out of Sierra Foothill Research and Extension Center. Jerry originally found the birds in this creek, Slicks Canyon, as part of an effort to do bird surveys prior to restoring a riparian wetland within the canyon with the goal of attracting, I believe, willow flycatchers. After discovering, he started doing surveys elsewhere in the Sierra foothills and found the birds were everywhere. I want to read a little bit here quick from his original report, which is that we began monthly bird counts along Slicks Canyon in 1994 as part of a project to restore riparian vegetation along the creek. We detected one black rail by a spontaneous kiki-cur call and 3 more by spontaneous kiki-cur calls, as well as one briefly crossing a gap in the cattails. After discovering them, because this is also a state-threatened bird, a more intensive research project was launched. By the time I started working on it, there had been a lot of monitoring, but not a comprehensive effort to map or understand what was going on with the wetlands themselves. So I went out and mapped all wetlands with satellite imagery, conducted field visits to all the different wetlands, or as many as I could get access to, surveyed the landscape, trying to figure out where their water sources were coming from, and talked to the landowners who often knew, like, oh yeah, that's a leak from my pipe that's busted underneath that patch of ground that was supposed to be buried here. I also examined historical aerial photos back to the 40s and used all of that information to determine what the water sources of these wetlands were. Overall, we found over 1,500 of these wetlands dotting the landscape, covering Yuba, Nevada, and Butte counties. And when we looked at the water sources of those Gold Country wetlands, we found that this was an increase likely 3 to 8 times their historic levels. Most of the wetlands were purely irrigation fed. Around a quarter of them had both irrigation and natural. So they were natural wetlands that had irrigation water added to them. And then just 15% were totally natural, largely within refuges or military bases. Because 85% of moderate foothill wetlands receive irrigation water, it's important also to note that nearly all of this irrigation is wastewater. It is the Gold Country where these irrigation infrastructure that was built during the early 1850s is just earthen ditches. So because of that, it's really leaky and really inefficient, and it spills out all of this water onto the landscape, which creates this habitat for these rails. But what do those changes actually mean for black rails? Are these good habitat actually, or are they just habitat? Well, we've done long-term monitoring of those populations since the early 2000s. The green is the population estimate. Red here is the rate of local extirpation from individual wetlands of birds. So the likelihood that a wetland is going to blink off. And then the birds will also colonize these wetlands again, because again, they're pretty small wetlands. So the population sizes are reasonably small in any given individual wetland. We can see that occupancy declined over time. There was one big extinction spike when West Nile virus emerged in the system in around 2006. But then there were also a number of spikes later on, around 2012 to 2015, when there was a historically severe drought in California. So are irrigated wetlands as good of habitat as natural wetlands? Well, I was fortunate enough to be surveying during this drought. And when we looked at that then, the occupancy rates of the different types of wetlands during the drought, we see a really dramatic and interesting pattern. By the end of the drought, black rails were absent in wetlands that were wholly natural. We did not find a single one occupying those birds. Irrigated wetlands provided better habitat actually than the natural wetlands, but most interestingly, the wetlands that received both irrigation and natural water were the best habitat. Why would that be? Well, this is a bit of a complicated graph, but I'm going to try to walk us through it. The x-axis is time, season of the year, over the course of several years of drought, with both the wet season in the winter and the dry season in the summer. The colors show the rainy periods, which is usually the winter, in blue, and the dry periods in red. And the y-axis is the percent of the wetland surface that is wet, which is what these birds really need for habitat. How wet or dry is the wetland? We can see that at natural sites, they flood up in winter during the rainy periods. Right up here, rains come, they get wet, and then the rains stop and they dry out. That's what we would expect in a Mediterranean climate. However, interestingly, the irrigated wetlands show the opposite patterns. They're drier in the winter and then get wetter in the summer. And that's because the irrigation water is switched off in the winter when there's usually enough rain to create green grass for forage anyway. and then they turn it on in the summer to keep those pastures green and growing when their cattle need forage in the summer. So because these two water sources responded differently to drought, the wetlands that received both water sources, shown in green here, were wet year-round. One source of water came into the system in the winter, one in the summer, and during non-drought years, which we saw in 2016, they were all pretty fine. None of them really dried out. But during the drought, that different response to drying was really important for maintaining the birds. This is a concept in ecology usually used to promote biodiversity called the portfolio effect. It says, let's say you have a meadow and that produces a lot of forage. Then if that's your goal, you should have a diversity of native grass species, because some grass species might grow best in a normal year, some might grow best in a dry year, some might grow best after a flood. And the response diversity of each of the different species increases the resilience of the system overall, ensuring it continues functioning during disturbances which are kind of naturally unpredictable. What I think this graph shows is that we should have a broader conception of diversity, not just diversity of ecological processes, but also of anthropogenic processes. Adding in different types of water flows stabilizes the system's function the same way that multiple species of grass can stabilize a grassland function. If we think about that from a policy perspective for a moment, not taking into account could detrimentally impact the wastewater that supports these ecosystems. During this period of the drought in California, there was a big drive towards efficiency in water use and fixing leaks. That could backfire and damage ecosystems overall if we're not accounting for how those inefficiencies and accidental habitats support biodiversity. And we did some simulations of landscapes and different drought policies and water regimes to see what the impact of those policies might be. This is the population size distribution of those simulations, and the number of simulations that drop below this red line here show the relative risk of the population going extinct. And we can see that we looked at policies to create and protect wetlands and whether those could reduce extinction risk. We found that creating more wetlands was really helpful, but if you have those drought cutbacks added into the system, because they hit the water when the birds need it the most, none of these policies really help in that instance, because that anthropogenic water is so crucial to continuing the function of the system. Interestingly enough, these kind of reverse seasonality wetlands did have an analog in the natural California landscape before Western colonization. There was a number of them that were wet in the summer in the Central Valley when snowmelt would run down through the system. But most of those have all been drained and converted to cropland. So I want to conclude this section by talking for a moment about the outcome for this one wetland where black rails were originally found. As I mentioned, they found the birds doing baseline surveys before a riparian restoration project, planting willows to encourage willow flycatcher to nest in there, which is another threatened species. As a result, the willows took over. It became a forested wetland rather than an herbaceous wetland, and that's not black rail habitat. Black rails aren't found in this wetland anymore. If we zoom out to California, I think that carry a bit of a cautionary tale for thinking about managing landscapes overall. How can we support wildlife and human communities in California as a whole? What unintended consequences are there to managing without understanding how birds are using degraded or artificial habitats? Water doesn't flow naturally across California anymore. Its flows are tightly modified and regulated by human activities, top to bottom. And the birds adapt their flows, their migrations to follow that water in turn. Other studies have shown that birds using the Central Valley portion of the flyway can shift to coastal areas during drought. We've seen evidence of that in the restoration project too, with bird abundance responding to annual weather, particularly shorebirds. And if we jump back finally to that mystery of the phalaropes, I think this same thing might be happening. Those huge spike years the eBird data shows in the 1980s were maybe because conditions were poor at saline lakes elsewhere. So you get 40,000 birds heading down to San Francisco Bay to use the salt ponds that aren't tied to the same weather that's vulnerable to climate change and all these other variability. Understanding the value of those marginal anthropogenic habitats and maintain that value for wildlife might be key to increasing the resilience of the landscape overall. And the fact that the decline happened historically, it's not so much that they decline. Since we've restored those ponds, maybe we just don't see them able to recolonize it the way that they used to be able to when they needed to adapt and use those landscapes in one-off years. As we go forward and experience a century of pretty much unprecedented climate change on top of ongoing land use change and changes in water policy, this diversity, I think, could be crucial to allowing birds to endure and adapt that unpredictable future. So, in conclusion here, I want to touch a bit on that broader picture with this great article in National Geographic that was published summarizing the Bay Salt Pond Restoration Project, where it talks about restoring nature's delicate balance. Don't get me wrong here. I think we absolutely need tidal marsh restoration to help birds like rails and to help human communities. But what I do think is that as a concept, that concept, balance, is what we need to move beyond. We're never going to get back to a Bay Area that looks like the image on the right there. We're never going to get back to a California that looks anything like what it used to look like. And we need to understand the ways the birds have responded negatively and positively to those changes, both of them. Leveraging the positive changes of those habitats, I think, is the only way we're going to scrape together enough resources to make sure that we can help nature endure all these coming challenges. So with that, I think we're ending just on time. I will also give a quick pitch that if you enjoy this talk and want to participate in the research that I presented here, this is a lot of it volunteer community scientist done research. The fallow data is collected by our volunteer surveyors every summer. We do California Gull walkthroughs. We're just starting up our colonial waterbird monitoring of herons and egrets, and are in particular short on volunteers in North Bay. So you can follow that QR code or just email me if you're interested in participating in any of those. We can always use more hands on deck. And with that, I'm happy to answer any questions folks have.
Thank you, Nathan. That was great. And I do see one question so far in the chat, and people can feel free to ask more questions. Also, Nathan, from our earlier conversation, there's now about 67 people. So I don't know if you think that's a small enough number that people can just unmute themselves and ask you questions.
Go for it. I'm happy to chat with people.
So Elaine's was the first question. I don't know, Elaine, if you want to just ask it or I can read it for you.
Sure, I can do that. So thanks for a really comprehensive talk, Nathan. Tons of data across everywhere. Do you have a link or PDF for that National Geographic article that you were citing? If you could just put that in there.
I do not have a link to it off the top of my hands. I would just Google it.
Okay, so is the title of it, this is Beyond the Balance of Nature? That is the actual title?
No, the title is on the left here, How the Bay Area is Restoring Nature's Delicate Balance.
Oh, this one here. Okay, great, thanks.
Yep. There is also a great paper on this topic, but I could not find an open access version of it. But it was a very seminal ecology paper back in either the late 90s or the early 2000s that was arguing the same thing about moving beyond balance of nature as a concept, and the importance of flux in ecosystems from a variety of different viewpoints and study systems.
Nathan, I don't know, can you see the chat or did you want me to read the next question out?
I cannot. If you could.
Okay, yeah.
Read it, that would be great.
So the question is, are you saying we should save some salt ponds and not move them back from natural?
I think there have been a lot of studies over the 2 decades of the project that have come to some degree at that conclusion. We know that there are going to be significant challenges associated with trying to support this many waterbird populations with the remaining with a significantly reduced amount of pond acreage. The challenge, on the other hand, and the salt pond folks know this as well, and they're working their best to try and manage this very difficult system with a lot of trade-offs. Two of the biggest trade-offs: one, we really need to protect communities from sea level rise, and there are also blue carbon benefits to tidal marsh restoration. And two, there's a real limit on the amount of ponds that they can retain long term, because the ponds themselves are, squiggly, divided up by all these squiggly levees, and those levees experience an enormous erosion pressure every year. So maintaining the levees actually is extremely expensive and going to get more expensive under sea level rise. The Don Edwards National Wildlife Refuge is actually the most expensive wildlife refuge in the country. So because of that, they're pretty much their hands are kind of tied, in terms of they feel like at this point they need to hit pretty near that 90% upper threshold of pond restoration. And the real challenge we're trying to figure out is how we can help the birds adapt to a landscape that's going to have significantly less habitat overall.
Thank you. Next question is there telemetry data available from the past and current data acquisition that can help track the change in use of the flyway by phalaropes from year to year?
So the phalarope project, we're one part of it. There was an international phalarope working group, which meets every 2 years. We had our meeting in Argentina at Laguna Marchiquita last year. And one of the main efforts that they are undertaking right now is to ban phalaropes and attach them with solar trackers that will highlight different dispersal amongst the it's not solar, it's MODIS. MODIS tags, which ping off of cell tower basically and can track the migration and the connectivity between those. We haven't done any banding ourselves yet, because Mono Lake and Great Salt Lake are the main current habitats that are being used. We're letting them kind of pilot it before we try to get in on there and really get the banding and capture techniques down. But we are interested in doing that probably in a few years once they've gotten the kinks worked out more broadly. And we have picked up a few migrants as well. At least one that was banded at Lake Avert and came down through San Francisco Bay.
Thank you. And just to note that someone did put a link to the National Geographic article in the chat if people are interested in that. I don't see any questions right now, but I'm going to ask a question. And if you guys have other questions or comments, thoughts, please put them in the chat to share with Nathan. Nathan, you mentioned a little bit the conference that you went to. I don't know if you wanted to talk a little more about what it was like to meet with those other scientists and some of the positive outcomes. And that's sort of the first part of the question. And the second is looking at the complexity of the issues that you're discussing. A little bit, if you want to speak a little bit about sort of the complex efforts of coordination that may be happening with groups like the working group or other agencies and partnerships and addressing these things, and basically reason to hope.
Yeah, I think the phalaropes in particular are a really promising new effort. It's probably the effort that I'm most excited about from what we're doing right now, both for having a really clear link to salt pond management in the Bay Area, but also a really good link to what's going on more broadly. The saline lakes issue is really crucial. It was one of the things I was working on at USGS. We just got a paper out doing a big review project on bird threats from the saline lakes crisis across the Great Basin. And despite it being such a major threat, there's been really surprisingly little research done on it. I think because for a lot of people, the saline lakes aren't like great areas to get out to. They're in the middle of deserts and they're very large and inaccessible generally. So they've been a bit out of sight, out of mind, I think. And there's a really renewed effort to focus on how eared grebes and phalaropes are being impacted by these efforts. The goal of the phalarope conservation, one of the main goals, is to use them as a flagship species to help advocate for the protection of these really unique ecosystems. And the fact that they do these big migrations from Canada all the way down to Argentina really, I think, highlights how all of the birds connect with all of these different countries. The working group meeting in particular was great. It was a lot of fun. I had not been to South America personally before, and I got a chance to check out the lake and do some birding around there with the other scientists, which was very nice, but also very productive getting to talk with some Argentinian scientists and some of them from Chile and other areas, and really, I think, help do some skill shares. The Bay Area, which is where a lot of the other researchers working in Valorous are based, are obviously very technically rich. We have a lot of resources in terms of science and GIS and all these things that I think it's exciting to be able to share. And to hopefully, one of the other reasons is hopefully getting more of the trapping and banding efforts going down there as well, spinning up those things. Yeah.
Thank you. There's a few more questions. There's one question that, let's see. Well, it was the beginning of the question. There's no name on it. It's a number, but it was, how does a natural habitat affect? And I think that wasn't a full question. So if that person wants to unmute themselves and ask the question, or if they want to finish the question, I don't know that if all of it got typed in. But in the meantime, Elaine says, you mentioned that some of the project surveys will continue with regular data collection and that you rely heavily on volunteers. How hard is it to find funding, and how do you choose one program over the other if you don't have the manpower or resources?
Finding funding for this work is a consistent challenge. Because we are not a university, we rely on partners often. A lot of big research funding is tied to, you must be at least associated with a university. So we work with people at Berkeley, at San Jose State, professors there. The benefit of being a nonprofit is that we can much more directly and rapidly work with community members and bring that citizen science angle to it. So that is kind of the two prongs. We do a lot of contract and grant applications with partnered with universities, and then we work with communities and try to be the bridge between those two different organizations and, I guess, associations. In terms of prioritizing what we can do, I think that the biggest asset, maybe I won't say the biggest, but one of the biggest assets that SFBBO has is that we've been doing these long-term monitoring projects for decades now. The Colonial Waterbirds project, which I didn't touch on much today, goes back to the 80s. The Salt Pond project is now 2 decades old. Our landbird station has also been monitoring landbird populations for a very long time. And when you have that annual data, you can do these really big scale studies where you're trying to disentangle landscape scale changes and climate changes and all of these things that are only possible with years and years of data. So that's always been my biggest priority when it comes to funding, is making sure that we can continue our long-term monitoring projects, because you can always analyze data later. If you miss a year, then you miss a lot of information about what's going on with those trends. So I've always prioritized getting the field work done first and foremost, and scraping together the funds to do the data analysis when I can.
Thank you. And I just want to acknowledge that we are at the end of the hour, but this is a good conversation. So if you need to leave now, thank you so much for joining us. And there are some more questions in the chat. And if you would like to stay and ask more questions and talk with Nathan, we invite you to stick around. And we do have some
comment. This is Vicki. I have a comment.
Vicki.
So I'm actually one of the original banders at Coyote Field Station, SFBBO, whatever. And we were, excuse me, always challenged about, why are we banding? And we'd say, because it's a longitudinal study. Well, what is it all about? And I'm just so glad through thick and thin, we prevailed. And that's all I have to say. Thank you.
Thank you,
Thank
Vicki,
you.
and thank you for your commitment to our project. We love hearing from our volunteers, and thanks for being here today. Sorry, Nathan.
Yeah, I think that the ability to use that sort of approach and to have the community scientists that are helping maintain these are the reason that we have longitudinal data. It is very, very difficult to get longitudinal data with funded scientific projects, because as soon as the grant goes away, that's maybe 5 years of data collection, and then it's very difficult to keep it going. So you all are the reason that we can do that. It's hard to do in science otherwise.
Thank you. And we do have the rest of that question. So it says, how does a natural habitat affect psychology of perception of wildlife now, as opposed to, say, the relationship between humans and wildlife 500 years ago?
Can you read it one more time?
Yep. How does unnatural habitat affect psychology of perception of wildlife now, as opposed to, say, the relationship between humans and wildlife 500 years ago?
Interesting. I think it's a complicated question. One of the ways that we relate to wildlife, I think, is by exposure to wildlife. And I do think that these anthropogenic habitats can give us good exposure to wildlife. I think that 500 years ago, people were much more integrated with nature and had were a bit more in tune with natural cycles, versus today, often we're relatively insulated from it, especially living in a major urban area like San Francisco Bay. I do think that one of the things that's really interesting about SF Bay is that there is these really remarkable wildlife populations, millions of waterbirds, huge amounts of biomass. They're right in folks' backyards. And more generally, natural ecosystems, gorgeous hiking areas that are next door to, places. As somebody from the East Coast originally, it blew my mind when I came out here, that it was all kind of smushed together. So I think that anthropogenic habitats from that standpoint, I think, have the potential to kind of bridge some of the disconnect from nature that I think modern society has otherwise brought about. And I think that trying to approach it from a viewpoint of stewardship, I think appreciating birds, using these areas, actually, I didn't even talk about this is the bird returns program on the screen here that I ended with, which is a program by the Nature Conservancy, partnered with Point Blue, to flood farm fields in winter, so that geese and other geese shown here and other waterbirds can use them as habitats. But I think that kind of, again, helps connect outcomes for people and outcomes for nature a little better. And I think that psychologically that it will help us see the value of conserving nature.
Well said. We have a lot of thank yous, a lot of people impressed by the presentation and the data and research you're doing and the work that we're doing as an organization. I do have one other question that I see. Could you explain more about the inverse correlation of salinity with fallow rope use, if I have that right? That's from Yvonne.
Yeah, I wish I could. Unclear. One of the things, we just piloted a study this last summer trying to look at foraging rates within salty versus less saline waters. And we do there see that the most foraging success is in the fairly salty, but not crazy salty ponds. So one possibility is that the biggest trend drivers were that maybe going towards middle salinity. So there were some super salty ponds, and then salinity decreased, and the birds increased then. That's a possibility. There's also a possibility that the reduction in salinity might cause a temporary boost in the abundance of invertebrates, and then over the long term, once the salinity stabilizes there, the birds aren't using it as much. It's still a preliminary finding, I think. We haven't published it yet for that reason. That we still want to really dig into it and figure out what's going on because it is very counterintuitive. Yeah, we have confirmed that they are foraging most effectively at fairly salty ponds still.
Great. Thank you, Nathan. And it looks like that's all of our questions. So if there's anybody else who has a question, you can jump in. Otherwise, thanks everyone. Thank you, Nathan, for a fantastic presentation and for the deep work that you're doing here at SFBBO. And thank you everybody for joining us. Thanks to all of our volunteers like Vicki, and thanks to all of our supporters. If you're interested in getting more involved, you can reach out to Nathan. You can also ask me if you have any questions, and we hope to see more of you at future birdie hours and also at our in-person events. So thanks everybody for coming, and I hope you have a great night.
SFBBO is a nonprofit. With your support, we will continue to inform decision makers, inspire people to act, and involve diverse communities in our work. Please visit our website to learn more and get involved today.